The Observer Effect. Introduction. What if your thoughts had the power to shape reality? What if the way you observe the world actually determines the experiences you attract? Science and spirituality have long explored these questions, but now, emerging discoveries in quantum physics suggest that the act of observation itself influences the very fabric of existence. In The Observer Effect, How Your Thoughts Shape Reality, we delve into the profound interplay between mind, perception, and the universe. Inspired by the quantum concept of the observer effect, where the mere act of observing a particle changes its behavior, this book reveals how our consciousness plays a fundamental role in shaping the world around us. By bridging the gap between physics, neuroscience, and personal development, we uncover how the principles of quantum mechanics can be applied to daily life, unlocking limitless potential for growth, transformation, and manifestation. This journey will challenge your understanding of reality, empower you with practical tools for conscious creation, and invite you to embrace a new paradigm, one where your thoughts are not just reflections of reality but architects of it. Whether you seek personal breakthroughs, deeper spiritual insight, or a scientific perspective on the power of the mind, this book will guide you toward harnessing the observer effect to reshape your world. The universe is waiting for you to take notice. The question is, what will you choose to see? The Observer Effect Unveiled. Bridging Quantum Mysteries and Human Consciousness. Introduction. Throughout history, scientific discoveries have continually reshaped our understanding of reality. One of the most profound insights of the 20th century emerged from the field of quantum mechanics, the observer effect. This principle suggests that the mere act of observation influences the behavior of subatomic particles. While initially confined to the microscopic world, the implications of the observer effect have sparked debates about its relevance to human consciousness and reality itself. Could our thoughts and awareness shape not just individual experiences but the collective fabric of existence? This chapter explores the scientific foundations of the observer effect, its philosophical interpretations, and its potential to redefine personal and societal transformation. The Quantum Observer Effect, Scientific Foundations. The observer effect is a cornerstone of quantum mechanics, first illustrated in the famous double-slit experiment. When electrons or photons pass through two slits without observation, they create an interference pattern, behaving as waves. However, when measured or observed, they act as particles, collapsing into a definite state. This experiment challenges the classical notion of an objective reality independent of observation. Physicists such as Niels Bohr and Werner Heisenberg contributed to the Copenhagen interpretation, suggesting that quantum particles exist in superposition, multiple potential states, until an observation forces them into a single outcome. This raises fundamental questions. What constitutes an observer? Does consciousness play an active role in this collapse? While some scientists argue that the act of measurement, rather than human consciousness, is the key factor, others propose a deeper link between awareness and the material world. Consciousness as a creative force. Philosophical perspectives have long entertained the idea that human consciousness shapes reality. Ancient Eastern philosophies, such as Vedanta and Buddhism, emphasize the interconnectedness of mind and matter. In modern discourse, the quantum observer effect has reignited these ancient ideas, aligning them with emerging scientific thought. The concept of participatory reality, proposed by physicist John Archibald Wheeler, suggests that the universe remains in a state of potentiality until it is observed. This idea implies that observation is not merely a passive act but an active process that brings reality into being. If consciousness influences quantum events at a fundamental level, then its role in shaping human experiences, decisions, and even broader societal structures warrants deeper exploration. Personal reality and the observer effect. If observation affects the quantum field, could human thoughts and emotions impact personal experiences? The law of attraction, visualization techniques, and mindfulness practices all hinge on the premise that focused attention and intention shape outcomes. Neuroscience supports this notion, revealing that brain activity, perception, and emotional states alter physiological responses and external interactions. For instance, the placebo effect demonstrates how belief and expectation can bring about tangible physical changes. Similarly, experiments in parapsychology, such as those conducted at Princeton's Princeton Engineering Anomalies Research Laboratory, suggest that human intention may influence random systems. While mainstream science remains skeptical, these findings hint at a deeper relationship between consciousness and reality. Collective consciousness and societal shifts. Beyond individual experiences, the observer effect could extend to collective human consciousness. Social movements, cultural transformations, and historical shifts often begin with a change in perception. When a critical mass of individuals adopts a new way of thinking, it can alter societal norms and realities. Rupert Sheldrake's theory of morphic resonance proposes that once an idea or behavior gains enough momentum within a group, it becomes more accessible to others. Similarly, quantum coherence suggests that synchronized thoughts or intentions among groups may create measurable effects in the physical world. Global meditation studies have hinted at reduced crime rates and increased harmony when large groups focus on collective well-being, though such claims remain controversial. Challenges and skepticism. Despite its intriguing possibilities, the application of the observer effect beyond quantum mechanics remains contentious. Critics argue that quantum phenomena do not scale to macroscopic levels in the way some interpretations suggest. The role of consciousness in wave function collapse remains an open debate, with alternative explanations favoring decoherence and environmental interactions rather than a purely mental influence. Furthermore, distinguishing genuine scientific inquiry from pseudoscience is crucial. While quantum mechanics provides a framework for understanding the microworld, stretching its principles to explain consciousness and human experience requires careful examination. Ongoing research in quantum biology, neurology, and psychology may offer clearer insights into the interplay between observation and reality. Toward a new paradigm. Despite skepticism, the observer effect invites a paradigm shift in how we perceive reality and our role within it. If observation and consciousness actively shape experiences, then personal growth, intention setting, and mindful awareness become tools for transformation. Recognizing our participatory role in reality empowers individuals and societies to cultivate positive change. From ancient wisdom traditions to cutting-edge scientific theories, the interplay between consciousness and the material world continues to intrigue and inspire. By exploring these concepts with open-minded inquiry and critical thinking, we move closer to unraveling the mysteries of existence. The observer effect may ultimately serve as a bridge between science and spirituality, uniting them in a deeper understanding of reality's interconnected nature. Conclusion. The quantum observer effect challenges the notion of a detached, objective universe by demonstrating that observation influences physical phenomena. Whether this effect extends beyond subatomic particles to personal and collective experiences remains an open question, yet its implications are profound. As we delve further into the mysteries of consciousness and quantum mechanics, we uncover the potential for human perception to shape not only individual realities but the collective world. By embracing a participatory view of reality, we empower ourselves to become conscious creators of our lives. The journey to understanding the observer effect is not merely an academic pursuit but a transformational exploration into the nature of existence itself. Quantum mechanics demystified from particles to perception. Quantum mechanics, a field that emerged in the early 20th century, has revolutionized our understanding of reality. It presents a world where particles behave as waves, observations alter outcomes, and matter exists in multiple states until measured. In this chapter, we will explore fundamental principles such as wave-particle duality, the double-slit experiment, and the role of measurement, while also examining their broader philosophical implications. 2.1 The foundations of quantum mechanics. Classical physics, as defined by Newtonian mechanics, describes a predictable universe where objects follow determined paths governed by force and motion. However, at the microscopic level, classical laws break down, giving rise to quantum mechanics. This new paradigm introduced concepts that challenge our intuitive understanding of reality, including the probabilistic nature of particles and the significance of the observer. 2.1.1 Wave-particle duality. One of the fundamental revelations of quantum mechanics is the dual nature of matter and energy. Particles, such as electrons and photons, exhibit both particle-like and wave-like properties depending on how they are observed. This duality, first proposed in the early 20th century, suggests that a single entity can behave as a discrete particle or as a continuous wave. 2.1.1.1 The nature of light and matter. In 1905, Albert Einstein explained the photoelectric effect, demonstrating that light consists of discrete energy packets called photons. This contradicted the classical wave theory of light and confirmed its particle nature. Conversely, experiments such as electron diffraction demonstrated that electrons, typically considered particles, also exhibit wave-like interference patterns. The de Broglie hypothesis, 1924, extended wave-particle duality to all matter, suggesting that particles possess wavelengths inversely proportional to their momentum. 2.1.2 The double-slit experiment. One of the most famous experiments in quantum mechanics is the double-slit experiment, which highlights the enigmatic nature of quantum behavior. 2.1.2.1 Experimental setup and observations. A beam of light or electrons is directed at a barrier with two slits. If unobserved, the particles create an interference pattern on the detection screen, characteristic of waves. When a measuring device is placed at the slits to observe which slit each particle passes through, the interference pattern disappears, and the particles behave like classical particles. This suggests that measurement influences the system, altering the outcome. 2.1.3 The role of measurement. Measurement in quantum mechanics differs significantly from classical observation. In classical physics, measuring a property, such as position or velocity, does not disturb the system. In contrast, in quantum mechanics, measurement collapses a particle's wave function, forcing it to assume a definite state. 2.1.3.1 The observer effect. Before measurement, a particle exists in a superposition of all possible states. Measurement forces the system to choose a single state, collapsing the wave function. This raises questions about the nature of reality. Does the universe exist in a definite state independent of observation? 2.2 Philosophical implications of quantum mechanics. Beyond physics, quantum mechanics introduces profound philosophical debates about reality, consciousness, and the role of the observer. 2.2.1 Reality as a probabilistic construct. Unlike classical physics, which assumes a deterministic universe, quantum mechanics suggests that outcomes are fundamentally probabilistic. The Copenhagen interpretation, proposed by Niels Bohr and Werner Heisenberg, asserts that reality exists as a probability wave until measured. 2.2.2 The many worlds interpretation. Proposed by Hugh Everett in 1957, the many worlds interpretation, MWI, suggests that every quantum event spawns multiple universes, each representing a different outcome. In this view, all possible realities exist simultaneously, with measurement merely revealing the branch we experience. 2.2.3 The role of consciousness. Some interpretations suggest that consciousness plays a fundamental role in shaping reality. The von Neumann-Wigner interpretation, for example, proposes that consciousness causes wave function collapse, implying a deep connection between mind and matter. 2.3 Quantum theories simplified. Understanding quantum mechanics does not require advanced mathematics. Instead, by focusing on key principles and their implications, we can grasp the essence of this fascinating field. 2.3.1 Quantum superposition. A quantum system can exist in multiple states at once until measured. Schrödinger's cat thought experiment illustrates this paradox. A cat in a box with a radioactive trigger is simultaneously alive and dead until observed. 2.3.2 Quantum entanglement. When two particles become entangled, their states remain correlated regardless of distance. A measurement on one particle instantaneously influences the other, defying classical notions of locality. Einstein famously referred to this as spooky action at a distance. 2.4 From quantum mechanics to perception. Quantum mechanics challenges our understanding of perception and reality. If observation influences outcomes, then our role as observers may be more significant than previously thought. 2.4.1 The interface between physics and consciousness. Some theories suggest that consciousness itself may be a quantum phenomenon. Theories such as quantum brain dynamics propose that neural processes exhibit quantum coherence, potentially influencing perception and cognition. 2.4.2 Implications for free will and reality. If reality is observer-dependent, does this imply a form of free will at the quantum level? Some researchers argue that quantum mechanics allows for non-deterministic choice, challenging classical notions of causality. 2.5 Conclusion: Bridging science and philosophy. Quantum mechanics is more than a set of equations, it is a gateway to understanding the nature of reality. Its principles challenge our deepest assumptions about the universe, from the nature of existence to the role of the observer. By demystifying these concepts, we gain not only scientific knowledge but also a deeper appreciation for the mysteries of perception, consciousness, and the interconnectedness of all things. As we continue exploring quantum mechanics, we are not only uncovering the secrets of the microscopic world but also gaining insights into the very fabric of reality itself. The journey from particles to perception reveals a universe far more intricate and mysterious than we ever imagined. Get your copy now on Amazon and start living quantum.